This is the OCR paper. It's paper 3. It's foundation paper. It's from Tuesday the 13th of June. So this is the very first of the new style papers that they sat in the summer of 2017. This is paper 3 and it is a calculator one. What I'm going to do is talk you through all the questions. I'll give you as much detail as I can, but obviously I don't want to make it go on for too long. Question 1, you don't even really need to read the question. It's fairly obvious what you need to do. It's convert fractions to decimals to percentages. So the top one is done for you. Right, the decimal, 0.27, I hope you'll recognise as 27%, because to go from a decimal to a percentage, you must multiply by 100, and that means to go the other way, you must divide by 100. Percent literally means, I think it's Latin or Greek, out of 100. So 27% means 27 out of 100. So there you go, 27 out of 100. The next one, 4/5. This is the tricky one. To go from a fraction to a decimal or to a percentage, you really need the denominator, that's the bottom number, to be 10 or 100. In this case, I'm going to make it 10. So that would be 8/10. I hope you understand what I've done there. So 8/10 is 8/10, and you need to know that 0.8 is 8/10. So that is 8/10. As a percentage, you multiply it by 100, so that is 80%. The next one, 3%, so that is 3 out of 100. 3/100ths is 0.03. As this is a calculator paper, you can cheat. You're not cheating because it's a calculator paper, but 4/5. If you don't know how to enter this into a calculator, you press the fraction button, which is up. Sorry, mine's a bit faded, but it is the third one down from the shift button, which is there, and you type in 4, and you go down 1 over 5, and if you press the equals button, you might have to SD it, which is this one here. It will tell you it's 0.8, which is what we got there, 0.8. It's really important you know those, not just for questions like this, but to be able to answer fractions and decimals questions confidently. Next one, write 45% as a fraction in its simplest form. Well, we use the same method. Percent means 100, so 45 out of 100, and it simplifies to 9/20 because 5 goes into them both, so 9/20. Next one, Alan and Brian share a sum of money in the ratio of 1 to 4. What fraction does Alan receive? Right, ratios, first thing, Alan and Brian, 1 to 4, because Alan comes first and the 1 comes first, so that means it's 1 to 4. Right, the important part here is what most people will put is 1/4. That's wrong. You need to recognise that there are 5 parts here in total. Alan's got 1 of them and Brian's got 4 of them. So there's 5 parts. What fraction does Alan receive? Well, he gets 1 out of the 5 parts. So he gets 1/5. 1 mark for that one. Question 2. Connie invests £8,400 at a simple, we'll talk about that in a minute, simple interest rate of 12% per year. Work out the value of the investment after 3 years. So basically that means she gets 12% each year. What's she going to have at the end of it? It's quite early on in the paper, so this is actually one of the nice easy ones. Simple interest is when you just find out what it is for the first year, then you just keep adding that number on each time. The other form of interest, which is the trickier one, is called compound interest. And compound interest is when you have to add the percentage on again. And obviously that money goes up, because as the money goes up, the percentage of it will get higher. Hopefully there's a question later on to have a look at. If you're not sure what I'm talking about, please ask your maths teacher. Anyway, 12% of 8,400. You might be tempted to do 10%, 1%, 1%. It's a calculator paper, make life easy. 12% is 0.12 as a decimal. So to work out 12% of 8,400, you do 0.12 times 8,400 is 1,008. Because it's 3 years and because it's simple interest, you want 3 lots of that, which is 3,024, then you simply add it on. So this is the value of her investment at the end of the 3 years, £11,424. Question 3, zoom in a little bit so you can see it. It says find the value of y. So 5 times 5 times 5 times 5 times 5 times 5 times 5 is 5 to the power what? It is 5 to the power 1, 2, 3, 4, 5, 6, 7. 5 to the power 7. So that means y is 7, because it should be 5 to the power 7. Next one, find the value of z. So you've got the value of z squared is 196. So basically, if it's an equation, you need to square root both sides to get the value of z. You've got a calculator, or some of you might recognise it, but you've got a calculator. So we're going to find the square root of 196, and that is 14. So z equals 14. Be a little bit careful here. There's 2 marks for it. It says 14 or what? You need to be aware that the square root of any number can either be positive or it can be negative, because obviously minus 14 times minus 14, a negative times a negative, will be a positive 196. Next one, expand and simplify. I've pretty much done it for you there, but I'll talk you through it. First bit, we'll do the expanding. So 5 times x is 5x, 5 times 2 is 10, and there's a negative. Right, next bit, minus 2 times x. You've got to use that negative because that goes with the 2. So minus 2 times x is minus 2x. Minus 2 times minus 4. A negative times a negative is a positive, and 2 times 4 is 8. That's your expanding. And your simplifying is there are 5 x's, take away 2 x's, so that will be 3x. And you've got minus 10, add 8, which is minus 2. So there's your expanding and your simplifying, 2 marks. Part B, factorise fully. 10x squared add 6x. Factorise means put into brackets, so you must know what the meaning of that. First of all, we'll deal with the numbers. What number goes into 10 and into 6? So what number is a factor of 10, hence factorise, and a factor of 6? Well, 1 obviously, but the biggest one in this case is 2. So you put 2 on the outside. Are there any letters common? Well, there's x squared there. Don't forget, x squared means x times x, or xx. So there's an x times an x there, or there's an x there. So the one that's common is an x. Then you draw your brackets. Right, 2 times what gives you the 10? 2 times 5 gives you the 10. And x times what gives you the x squared? X times x. There's a plus. 2x times what gives you 6x? Well, you've got the x, so you don't need that. And 2 times 3 is 6. You can always check those because you can multiply it out and you'll get what you started with. The next one, this is 4C, simplify. You cannot get this wrong. This is dead easy, I promise you. There we go. So x to the power 5 squared. If you square anything, it means you multiply it by itself. And hopefully you'll recognise this. You've got to use your index laws when you're multiplying and the x's are the same. You just simply add the index numbers. So the answer is x to the power 10. So x to the power 10. Next one, question 4. Question 5. Have I missed a question out? No, that was question 4. Question 5. Here we go. Find the value. Okay, this is a substitution question. Find the value of 3a, add 2b when a is 16 and b is 7. Right, if a is 16, 3 times 16 is 48. If b is 7, 2 times 7 is 14, and you're adding them up. So 48 add 14 goes to 58. 62 is your answer to that. 62. Next one. Use the formula. It's probably more substitution. We'll have a look. V equals u plus at. This is one of Newton's equations of motion. You should have learnt it in physics really, or science, but V is velocity. U is initial velocity, so that's velocity at which you start it. A is acceleration due to gravity, and T is time. Acceleration due to gravity, we tend to use 10 meters a second squared, but sometimes you can use 9.8 or even better 9.81. But we'll have a look at the question, see what it says. So to find the final velocity when the initial velocity is 2 meters a second. So the initial velocity is 2, so I'm going to put a 2 under here. The acceleration, oh okay, fair enough, so it's something different, is 1.5, so you add on, and you're timesing these, so I'll put this in brackets, 1.5, and the time is 6. So you need to work out that, so velocity equals that. Let's work the bracket out first. Velocity equals 2, add, use your calculator, 1.5 times 6 is 9, so velocity is 2, add 9, so the velocity is 11. Part C, so 5C, make D the subject of the formula. That means rearrange it so D is on its own. What we're going to do, okay, what's happening to D? D is being multiplied by 7. So you need to ask yourself, like when you're solving an equation, what is the opposite of multiplying by 7? It is dividing by 7. So we're going to divide both sides by 7. So C, scratch that, ignore that, divide by 7. So C divided by 7 equals, and divide by 7 and does the times by 7 is D. So the answer is D equals C divided by 7, because you're dividing both sides by 7. Question 6. Okay, do part A first. Henry puts 8 counters into a bag. Each counter has a different whole number on it between 1 and 8. So that makes sense. 8 counters, 1, 2, 3, 4, 5, 6, 7, 8. If you don't like this, you can just draw 8 circles and label 1, 2, 3, 4, 5, 6, 7, 8. He picks a counter at random from the bag and the number is noted down. Choose the words from the box to complete each sentence. It is what that he picks a number less than 9. Well, because the numbers in there are 1, 2, 3, 4, 5, 6, 7, 8, it is certain he will pick a number less than 9. It's not likely, it is certain, it's bound to happen. He picks an odd number. Well, the odd numbers in there would be 1, 3, 4, 5 and 7. So there's 4 odd numbers in there, 8 numbers altogether. So if you want to put it as a fraction, it's 4 over 8, which equals a half, which is evens, or a 50-50 chance. But you must write evens. Next one. Zoom out a little bit, my eyes are a bit funny. The Venn diagram shows a number of students who passed their examination in French, that's marked with the F, and those who passed it in maths, and the number of students who did not pass either is B. Okay, find the value of B. The total number of students is 55. Okay, so what I've done total number is 55. There's 18 in this part. There's 21 in the middle, and there's 10 in this part. So you take them away and you get the answer to be 6. That means out of 55 of them, 6 did not pass either exam. The next one, one of the 55 students is selected at random. What's the probability that this student has passed both? Well, there's 21 of them has passed both, so it's 21 out of the whole lot, which is 55. The next one, passed exactly one of the 2 subjects. So there's 18 people here who have just passed French. There are 10 here who have just passed maths. So out of these 18 and these 10, all of them have passed just one subject. So there's 28 who have passed just one subject, but because it's asked for a probability, it is out of 55 because there are 55 in total. Moving on, question 7. Here we go. Hardy buys 11 identical shirts and 24 identical ties for £403.51. Find the cost. The cost of a shirt is £15.65. Find the cost of a tie. Right, it's 4 marks for this. The workings are all pretty much there, but I'll talk you through it. First of all, the cost of 11 shirts will be 11 lots of £15.65, which is £172.15. As bizarrely as it seems, you will get a mark for that in the exam. Right, the total cost then of the 24 ties is the total amount. Take away what the cost of the shirts is, and that leaves you with the cost of the ties of all 24. So they're all 24, cost £231.36. You only need to find the price of one of them, so you divide it by 24 and it is £9.64. 4 marks, fairly straightforward. Please try not to make any mistakes. Question 8. Harry needs to go on holiday. So this is probably a currency conversion question. He can buy $50 for £40. How much will $720 cost at the same rate? Okay, so what I've done, I've worked out that it is 80 pence to $1. 80 pence to $1 by doing 40 divided by 50. So what I'm going to do is multiply 720 by 0.8, which I got before. It's 80p per dollar, and it gives me £576. Right. The way I would do this, because that's all lovely and that, but you need to notice that if you've got $50, the amount in pounds, although it's not less, it's a lower number. So the answer to this has got to be less than 720. You've got to find the conversion factor yourself by doing that division, and then you use that to find how much you get in pounds. Have a bit of a play with that one if you're not sure, but I want you to recognise the answer is going to be less than 720 by... Well, if you want to be funny about it, it's actually 20% less, isn't it? Because 10% is $5, so you could have just taken off 20% and you would have got 576. Next one. Tony returns from holiday with these notes. He's been to Europe because they're in euros. Zoom in so we can have a closer look. So what I've done, look, I've just worked how much money he's got. I think I even did that before I read the question because I thought that's what they're going to ask. So I hope you can see what I've done. Obviously, if he's got two 50-euro notes, it'd be 100 euros. Added them up, 330 euros. Work out how much he will get back in total when he changes these notes. Again, there's your exchange rate. Because pounds is a lower number than euros, the answer is going to be less. So you need to divide by the 1.17 and you get £282.05. Bit of a tricky one that, but if you're not sure, you can pick up 1 or 2 marks quite easily at the top just by doing that. Okay, question number 9. A bit of rounding. Round 7.3065 to 2 decimal places. So that's going to become 7.3. Right, at the moment it's 0. So look what's after the 0. Will that round up a 0 to be 1? Yes, it will, because it is more, well, it is 5 or higher. So 7.31 is your answer to that. Round each number to 3 significant figures. So that means you can write down 3 sort of whole numbers, then you've got to start putting some zeros on the end. So it'd be 4, 0. So it's, look what's after the 8, it's a 2. Will a 2 round it up? No, it will not, so it stays as an 8. And then you've got to replace the 231 with your zeros. That is to 3 significant figures. Next one. Now you don't count the zeros when you round this before the number sort of starts properly. So 0.006, make that 6, 1. Right, 613. Look, that's after the 3. It's a 7. Will that round it up? Yes, it will. So it'll be 614. So 0.00614. Question number 10. Write down the second and third terms of the following 2 sequences. And there's a rule here. To get the next term, subtract 4 from the previous term. This looks suspiciously easy, so let's read it closely. Write down the second and third term. So to get the next term, subtract 4 from the previous term. So just subtract 4. So that will be 15 and 11. That's probably the easiest mark I've ever seen. Next one. To get the next term, multiply the previous term by 5, then add 3. So we're going to multiply that by 5, which is 35, and add 3, which makes it 38. And to get the next term, we've got to multiply it by 5. Here's your calculator. So 38 times 5, and then you need to add on 3. Add 3, and it is 193. Let me show you something. Do not do this. This is important. Watch this. Do not do 38 times 5, add 3. In this case, you'll get away with it because of the way BidMass works, but when you get a calculation like this, try and do it step at a time. Obviously do your multiplication first. But in this case it would work, but please be really careful. If it was 38, add 5 times 3, you couldn't do it like that. Right, next one. Here are the first 4 terms of another sequence. Write an expression for the nth term. So what you do, you see how much it's going up by each time, and this looks to be going up in 4s. So the first thing we write down is 4n. Okay, that's the first term of the sequence, second, third, fourth, and so on. So 4 times, these are n values by the way, so 4 times 1 is 4. How do you go from 4 to 5? You add 1. Let's check that. 4 times 2 is 8, add 1 is 9. 4 3s are 12, add 1 is 13. So the answer is 4n, add 1. 2 marks. Question number 11. Grapes cost £2 per kilogram. Wrong way. There you go. Calculate the cost of 380 grams. Right, what I've done is I've found the cost per gram. So you need to know that 1 kilogram is 1,000 grams. Don't forget, and I've mentioned this before, the word kilo means 1,000. So if we think of kilograms, it's literally 1,000 grams. 1 kilometre, or kilometre, but kilometre is 1,000 metres. So to find the cost of 1 gram, you just divide that by 1,000. And then of course you must do the same to the price. So £2 divided by 1,000, that is going to give you, press the SD, 0.002. That's still in pounds. I'm not converted it to pence, it's still in pounds. Then that's 1 gram. So now you want to know the price of 380 grams. So you multiply both sides by 380. So we multiply this one by 380. And that gives you 0.76. And because it's money, don't forget your pound sign in front. The answer you can either put, well actually it's got a pound sign there, so you must put 0.76. If you put 76p over here, I think it would be a bit mean if they took the marks away, but there is a pound sign there, so it looks like they want it in pounds. Next one. Ruth buys 19 identical calculators for £280 and 25 pence. Estimate, sorry, I don't know why I said calculators. Ruth buys 19 identical tickets for £280 and 25 pence. Estimate the cost of 1 ticket. There are 2 answers for this. You can either do 280. So you've got to round that to 280, and you could divide that by 20, and that will give you 140. 140. No, I won't give you 14. Sorry, I'm going daft. 14. So that will give you £14. Or the mark scheme said it would accept you doing 300 divided by 20, which would give you £15. As long as you've shown one of these sets of workings, you'll be absolutely fine. If you don't like setting it out like that, you could always set it out like this in the traditional way. 280 divided by 20 equals 14. But regardless, you must show your workings, and a key word there is estimate. So we're rounding these off to nice numbers that are easy to deal with. Okay, question number 12. The shape below is formed from a rectangle measuring 12 centimetres by 15 centimetres, from which a rectangle length of 7.4 has been removed. That's all very interesting. Work out the perimeter of the shape. Well, perimeter, keyword, it's around the outside. So I'll just start you off. That's obviously 15, because it says so. That's 12, so that means that must be 12 as well, centimetres, because opposite sides of a rectangle are the same. That is 7.4, and that is 7.4 for the same reason. Opposite sides of a rectangle must be the same. So the only length we don't know is this one here. Okay, the whole width, is 15 centimetres, and you see there. So if we take away this bit, which is 5.8, And if we take away this bit here, which is 6.3, you'll see my calculations there, it leaves you with 2.9 centimetres. So that means it's 2.9. I really strongly suggest you go around and label this when you're doing it, just to make it easier so the examiner can see what you're doing. So the perimeter is all of these added up. So 15, add 12, add 12, add 5.8, add 7.4, add 2.9, add 7.4, add 6.3, gives you 68.8 centimetres. I'll leave that there. That's all the workings I've done for it. Obviously I should put that down there on the answer line, but I'm just doing it there so you can see it all on one page, I hope. Fairly straightforward. Question 13. The mass, which is M, of a girder is 12.7, correct to 1 decimal place. Complete the error interval. So that means if it's been rounded to 1 decimal place, what's the smallest it could be? So basically, what's the smallest number that we round up to 12.7? And the answer to that is 12.65. That would round to 12.7. There is nothing lower than that. That would still round to 12.7. So that means it's less than or equal to, but it could be up to 12.75. And I was trying to zoom in on this. It's really subtle, but look, this one here hasn't got that other equal sign on, so it just means up to 12.75. It doesn't necessarily mean it's equal. Well, it means it's not equal to 12.75, because obviously that would round to 12.8. But because it's only up to it, we put 12.75. In fact, when you do any question like this, you would always put, in this case, 12.75. I like writing up to, but in this case you don't need to. But there we go. Next one. The length of a piece of wood is given as 8 metres, correct to the nearest metre. So the smallest it could be is 7.5. The longest it could be is up to 8.5. The length of a metal rod is given as 8.5 metres, correct to 1 decimal place. So the smallest that could be is 8.45, and the longest it could be is 8.55. Show that the piece of wood could be longer than the metal rod. So what you've got to do is basically what you've done above, look. So they've actually set you up for this question here. So the wood, because it's 8 metres, correct to the nearest metre, could be as low as 7.5, but also it could be up to 8.5. So that's my bit of wood. The metal could be as low as 8.45, because that rounds up to 8.5, or it could be up to 8.55. So the wood could be 8.49 metres long, because that is less than that, and it could be 8.49 metres long. And the metal could be 8.45 metres long, because that's as low as it could possibly be. So we have shown that the piece of wood could be longer than the metal rod. And obviously if you look at the numbers above, the piece of wood did appear to be shorter. So these error intervals are pretty important. Question number 14. Right, triangle A and triangle B are drawn on the coordinate grid. Translate triangle A by the... Okay, first of all, translate. Translate is when you slide it around the place. So if I'm gonna, and it's a daft example this, but if I'm gonna translate my calculator, that's when you move it across and then you move it up or you move it down. Okay. Rotation is when you rotate it, fairly obviously, and reflection, that is when you flip it over. All right. So we're doing translation. That's like basically sliding it around the place. Right, let's zoom in on the vector. The top one means across, and the bottom one means up or down. You need to know that a +3 means you're going to go to the right, and a -5 at the bottom means you're going to go down. So it's going to go basically right 3 spaces, down 5 spaces. Make sure you use a pencil to do this. I think I've got one here. So we're going to go right 3 spaces, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. Okay, that is that point done. Now let's do this point here. 1, 2, 3, 1, 2, 3, 4, 5. For those of you who are pretty good at this, you'll notice that the last point will go there, but let's just do it anyway. 1, 2, 3, 1, 2, 3, 4, 5. And obviously when you're in the exam, you must connect these up with a ruler, and I suspect it said label the shape something. I can't remember, but when I finished doing my magnificent work with the ruler. No, it doesn't. It doesn't say label it anything at all. Oh well, never mind. Right, next one. Describe fully the single transformation. So it's either a reflection, a rotation, a translation. It's clearly not an enlargement in this case. That maps A onto triangle B. Right. It's not been translated because you see there are different ways around. It's not been reflected because otherwise that pointy bit would be pointing out this way. So it must have been rotated. So there's 3 marks available. Be really careful on this. You get 1 mark for saying rotation. And it's A onto B. So it's going from there to there. It looks like to me it's been rotated 90 degrees clockwise around the point, or around the origin basically. But let me just check that and I'll write it down. So there's my tracing paper. That tracing paper works really well on here, doesn't it? There we go. Anyway, so I'm speculating it's been rotated 90 degrees, so a quarter of a turn clockwise around the origin. So I put my pencil on the origin, and I hope you can still see it. Now I'm going to try and turn this, and I want you to watch it and see if my prediction is true. There we go, lucky guess. Lovely stuff. So you can see it's a rotation. Whoops, there we go. 90 degrees, or a quarter of a turn. There you go, near enough. So, rotation, 90 degrees. You could say a quarter of a turn, but that's fine. Clockwise. And you must say what point it is around. So, around the O-R-I-G-I, around the origin. You could say around the point 0, 0. Either is fine. Right, so your marks for that, it's 3 marks. 1 mark for rotation, 1 mark for the amount and the direction, and 1 mark for around which point or the centre of rotation, or whatever you've been taught to call it. But you must say that bit. Right, what are we on? Question 15 now. Here we go. Right. Students at school must choose 1 subject from option 1 and 1 subject from option 2. I expect you've all been in this situation. The subjects are given below. There they are. Work out the percentage of all the subject combinations which have exactly 1 language. Right, the only way I think to do this, and without trying to be too clever, is to work out all the possible combinations. So look, you see what I've done, I hope. French, Spanish, FS. You can have French geography, French history. I hope you can see where these are coming from. You can have art, Spanish, art, geography, art, history. You can have music, Spanish, music, geography, music, history, and economics, Spanish, economic geography. You get it. Right. Work out the percentage of all subjects that have exactly 1 language. Right. First of all, how many of these have exactly 1 language? Well, that one's got 2 languages, so that's no good. So I put a little line through that. Exactly 1. French and geography, French and history, that's exactly 1 language. Art and Spanish, that's exactly 1 language. Art and geography, neither languages. Art and history, neither. Music and Spanish, yep. Music and geography, no. Music and history, no. Economics and Spanish, yes. Economics and geography, no. Economics and history, no. So it is 1, 2, 3, 4, 5 out of a possible total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I didn't. It is 5 out of 12 as a fraction. So we've got to now convert that fraction to a percentage. And you're very lucky, it's a calculator paper. So if we press our fraction button, you can do 5 over 12 equals SD it. And that is 0.416 reoccurring. And I expect you to know how to convert that to a percentage. You multiply it by 100, which is 41.6 reoccurring percent. And that is your answer. Another way of doing 5 over 12, look, is just doing 5 divided by 12. You'll get exactly the same answer. SD it times by 100. All right. So 41.6. But you must set it out like this. You can't do it unless you've done what I've done. You could write the full names of the subjects out if you want, but you really don't need to. Go back, double check that, triple check that. It is 4 marks. You should be getting all 4. Next one, question 16. The owner of a tourist attraction records the amount of rainfall in millimetres and the number of visitors each day. The results for 10 days are shown in the scatter diagram. Ta-da, there it is. Circle the outlier on the diagram. Well, the outlier is one that doesn't really fit in with the general trend, and the general trend is going roughly where my pencil is. So is there one that is sticking out like a sore thumb? Yes, there is. It is that one there. That is the outlier in this case. The owner claims he would expect around 320 visitors on a day with 2 millimetres of rainfall. Does the scatter graph support his statement? So explain your decision. So basically, you've got to draw your line of best fit here. So a line of best fit is literally what it says, a line that fits the best. There are 10 crosses. We're going to get roughly 5 on each side. Not exactly, just roughly be fine. See-through ruler makes this a lot easier. I reckon that is something like it there. So there's my line of best fit. That'll do. Right, 320 visitors on a day with 2 millimetres of rain. So 2 millimetres of rain going up like that. And how many visitors would he get? I reckon he would get 240. So does it support his statement? I would say no. My line of best fit shows he should expect about 240 visitors. I mean, I'll be honest, it's a little bit hit and miss, these things, because I think days of the week have a really big impact on this sort of thing. But anyway, there we go. Right, part 3. Explain why the scatter diagram should not be used to estimate the number of visitors on a day with 9 millimetres of rainfall. Right, 9 millimetres is over here. We shouldn't use it for this. Well, apparently the line of best fit doesn't go through it. But the expression I want you to use for things like this is because it is outside the range of data collected. He has not collected, or she has not collected any data actually beyond 5.5 millimetres of rain. So you can't start estimating the number of visitors with 9 millimetres of rain in the same way you couldn't do it if there was 100 millimetres of rain all the way over here. It's just not suitable. So it is outside the range of the data collected. As long as you say that in a roundabout way, you'll be fine. Right, question 7. Oh, it's still the same one. Question 16b, pie chart. Here we go. The pie chart summarises information about the visitors to the tourist attraction on a different day. Right. Explain why the pie chart cannot be used to work out how many adults visited on that day. First of all, you're not told how many people visited it overall. For example, if you were told there are 100 people who went, you could probably work out if 100 people went, probably about 40 adults, probably about 60 children. It's only roughly, but it's probably about that. But because you're not told that, and the question says, explain why the pie chart cannot be used to work out the number of adults visited on that day. The answer is, a pie chart is used to show proportion. So this pie chart shows me that more children went than adults, but this sounds a bit daft. Theoretically, you could have had 6 children who turned up and 4 adults. You could have had 6,000 children who turned up and 4,000 adults. You simply do not know, because you don't know the total number of people who went. So a pie chart is used to show proportion. If you want to give that example about the 6 children, 4 adults, or it could be 6,000 children or 4,000 adults, please write that down as well. Right, moving on. Question 17. The scale on a map is 1 centimetre represents 25 metres. Work out the length in centimetres of a path on the map. Right, the path in real life is 240 metres long. So basically, every 1 centimetre on the map is going to be 25 metres. So how many lots of 25 metres do we need to go into this? You do the calculation, 240 divided by 25, and I think it's probably about 9.6, but we'll do it just to be sure. About 25, it is 9.6, very good. So it'll be 9.6, and it'll be centimetres on the map. Okay. Right, next one. The scale 1 centimetre represents 25. Can be written in the form 1 to k. Find the value of k. So 1 centimetre to 25 metres. The problem with that is they're in different units. So when you do ratios, they've got to be in the same unit. So let's convert that to centimetres. So 1 centimetre, and you need to know there's 100 centimetres to a metre. So you times that by 100, 2,500 centimetres. So if it's 1 to k, it'll be 1. There's 1 already there, to 2,500. Next one, the scale drawing represents a park. 1 centimetre represents 25 metres. Got all that lovely stuff. Let's zoom out a little bit so we can read the question. A new play area must be no more than 150 metres from B. Right, let's do that. You're going to need one of these, and I'm going to get out my ruler again. This is what you do. First of all, when you use your compass, or a pair of compasses if you want to be really accurate, you make sure they're at the same height when you do them up like that. I'll be honest with you guys, these are so cheap. Unless you've got a really good one, get a decent one before the exam, or a new one, because these screws tend to come loose and you don't want to go into an exam with a floppy compass. It'll be embarrassing. Right, anyway, no more than 150 metres from B. Well, I'll go to my scale, 150 metres, well, it'd be 25, 50, 75, 100, 125, 150, so it's 6 centimetres. So you get your ruler out, you measure this one to 6 centimetres, be as accurate as you can. That's roughly there, I think, isn't it? I don't know why that's moving. There we go. So what you do, you put that on B. I'm going to turn this upside down a minute, so I can't do it the other way up. So you put the point on B, and the play park can be no more than 150 metres from here. So it must be inside this area. Turn it the right way up. So the play park must be in there. You've probably got 2 marks just for doing that bit. What I'm going to do is just go over a little bit darker, because I'm a bit conscious it's not showing up on your screens on YouTube very well. There we go. I hope that's a little bit clearer. Right, and it must be closer to AD. Right, AD is that line there, than to CD, which is that line there. So this, I guess, is vaguely tricky, I suppose, but it must be closer to this line than this line. So basically, there's going to be a line that's going to be drawn roughly up here somewhere. Essentially, if you know what you're doing, you'll be all right with this. You need to construct you need to bisect this angle down here. So we're going to cut that angle in half. You can't measure it with a protractor. You must do this, and it says you must show your construction line. So all you do, it doesn't really matter how long this is. I'm going to keep it, well, I'll do it a little bit smaller, I suppose. Keep it something like that, and the width of this doesn't matter now, because you're going to do one little arc there to cross that line, and you're going to do another one at the top. There you go. And then you're going to do one sort of swoosh from this point, and then you're going to do the same thing from the other point you've drawn, and there you go, bingo. So where those 2 lines cross, which is here, that is where you draw your angle bisector. Just take it out of the compass, I finished with that, it's a bit fiddly. So you start from here, and you go up, and you go through there. Happy days, there we go. Leave your construction lines on, the examiners love that stuff. Right, construct and shade the region where the player can be positioned. Right, so it's got to be inside this little arc here, and it's got to be closer to AD. So it's got to be close. So it's got to be below this line. So the region it could be in is this bit here. Don't spend ages shading it in, but the examiner sees that. Let me do it a bit darker because it doesn't show up. If the examiner sees that, they'll be very happy. Okay? Actually, they won't be, because I want you to do better shading than I've just done. But you get the idea, okay? There you go. When I was marking, I would have given that marks because the construction lines are there. So it's all good. Right, let's see if we can get one more done before I go and teach. A village has a population of 4,200 and a population density of 700 people per kilometre squared. Right, this is going to be about population and population density. So a village has a population of that and a population of density of 700 people per kilometre squared. So if in 1 kilometre squared there's 700 people, how many kilometres squared is the village? Well, you could do 4,200 divided by 700, or you could go up in 700s, but basically the area of this village, or the size of this village, is going to be 6 kilometres squared. An estate has been built. It's got an area of 2 kilometres squared and a population density of 800 people per kilometre squared. So for every kilometre squared there's 800 people, there's 2 kilometres squared, so there must be 1,600 people. Work out the total, work out the population density for the village and the estate together. Right, well the total area is 2 kilometres squared as 6 kilometres squared, so it's 8 kilometres squared, and the total population is 4,200 and 1,600, which is 5,800 people. So in 8 kilometres squared there's 5,800 people. I want to know how many people live in 1 kilometre squared, because that is population density. So you do 5,800 divided by 8, and that gives you 700 and something, 525, and that is people per kilometre squared. Right, so 725. A little bit nasty, but well done if you've done it. Right, let's try and get this one done. Question 19. I found this one just really annoying, to be honest with you, but let's have a go. Two numbers have these properties. Both numbers are greater than 6, so that's fairly obvious. It could be 7, 8, 9, 10, 11 or 12. Their highest common factor is 6. So 6 goes into them both, and it is the biggest number that goes into them both. So just trying to do the biggest number that 6 goes into. So the answers could be, well, it couldn't be 6, it could be 12 and 18 maybe. The highest common factor of them is 6. It could be maybe 18 and 24. It could be 12 and 30. Do you see what I mean? All of these pairs have a highest common factor of 6 anyway, and the lowest common multiple is 60. So that means they all go into 60. So they all go into here. So what I'm going to do is go around and I'm going to get rid of the numbers I know it definitely is not. First of all, it is greater than 6. So it can't be that, 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 and can't be that. Right. The highest common, so we've done the top bit, we've done that bit. The highest common factor is 6. So 6 must go into it. So 6 doesn't go into that, it doesn't go into that, it doesn't go into that. So we're left with 12, 60, 12, 30, and 60. Right. The highest common factor is 6. Well, the highest common factor of 30 and 60 is 30. The highest common factor of 12 and 60 is 12. So it comes. Question 19. Two numbers have these properties, and it gives a list of properties here. This is testing your knowledge of whether you know what a highest common factor is and whether you know what a lowest common multiple is. Just a quick reminder, a factor is a number that goes into another number. So for example, the factors of 60 I've done here, the numbers that go into 60. And lowest common multiple, for a number to be a multiple of something, that means it must be in its times table. So first of all, what I've done, I've gone through all the factors of 60, because it has to go into 60, so and there they all are. And I've crossed off the ones that are less than 6 or 6 or less. And then I've also crossed off some other ones as well. It can't be, because their highest common factor is 6. So for example, it can't be 10 because 6 doesn't go into 10. So what I've done then, I've come up with the possible combinations of numbers it could be. So it could be 12 and 18, 18 and 24, or 12 and 30. Well, if we look at this, they've all got to be a multiple of 60. So 18 is not a multiple of 60, so neither is 24. So the numbers must be 12 and 30. That's 12 and 30 because their highest common factor is 6. 6 is the biggest number that goes into them both. And their lowest common multiple is 60, because 30 goes into 60, and so does 12. It's a bit of a fiddly one, that, but if you know what a highest common factor and a lowest common multiple is, you should be able to work it out. Question 20. Here is a fair 5-sided spinner. Kira spins the spinner twice and records the product of the two scores. I've underlined the word product. To answer this question, you'll need to know that product means multiply. So she spins it twice. So for example, if she gets a 2 and a 2, 2 times 2 will give you 4. So down here, I've basically multiplied them all together. So you hope you can see, obviously 16 is 4 times 4, 12 is 3 times 4. So I've filled that in. You get 2 marks just for doing that, which is very generous. Next one, find the probability that the product is a multiple of 3. Well, what you need to do is go through here and see which of these numbers are a multiple of 3. So let's just go through it one at a time. So that 3 is a multiple of 3. 6 is a multiple of 3, and again 6 there. You've got 3 is a multiple of 3, all of these ones it will be. And then 12 is also a multiple of 3. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9, and the total number there are 25. So the probability is 9 out of 25, or 9 over 25. You must write that as a fraction. I suppose you could put it as a percentage, but just keep it easy for yourself. 9 over 25, and I hope that makes sense what I've done. The next one, Kira makes a different 5-sided spinner. She spins the spinner twice and records the product, again multiplying, of the two scores, and she says the probability that the product, so the answer, is negative is 0.48. Write numbers on the spinner so that Kara's statement is correct. Right, this is a really nasty one for 3 marks, and it's, you know, if you're looking at getting a 5, this is the one you should be getting, but it is very difficult. The probability that the product is negative is 0.48. Don't forget, to get a negative answer when you multiply, and that's what it's talking about here because it's product, you have to do a positive multiplied by a negative number. So it's just under 50-50, isn't it? So what we're going to do is put in some negatives and some positives. The numbers you put in don't really matter as long as you get the sign correct. So you could call them all -1 if you wanted. I think that would probably work, but we'll just change it up for some fun. So -1, -2, and we could have 3, 4, and 5. Right, so to get a negative answer, first of all, you're going to have to spin either a positive or a negative, but then your next spin, you're going to have to spin something, basically the opposite sign. So you could do -1 times 3, -1 times 4, -1 times 5, or -2 times 3, -2 times 4, -2 times 5. They will all give you negative answers. In order to work this out at the end, it's a little bit fiddly and it does take a bit of time, but the answer is you either need 2 negatives and 3 positives, or you need 3 negatives and 2 positives. It doesn't matter which way round you go, but you must have 3 of one and 2 of the other. Bit of a nasty one, that. If you're not sure about it, don't worry too much about it. Next one, question 21. 21a, complete the table for x squared minus 2x. They've done most of it for you, but let's just look at this one to make sure we can do it. X squared, well, x is 4, so 4 squared is 16, and it says take away 2 lots of x. So take away 2 lots of 4 is 8, 16 take 8 gives you the 8, so that gives you the 1 mark. The next bit you've got to do is to plot those points, so draw the graph. So what I've done, I hope you can see it, I've plotted the points already. So for example, you need to plot the point minus 1, 3. So remember, along the corridor, up the stairs, minus 1, 3, 0, 0, then it's 1, minus 1, then it is 2, 0, 3, 3, and 4, 8. I'm just taking the coordinates from up here. Look. Next thing you've got to do is actually draw the graph. Now, because this is a quadratic graph, it's not a linear one, which is straight, it's a quadratic, the line is going to be curved. So this is where you've got to be quite handy with a pencil, and I'll tell you as I go what we're doing. The mark scheme says you need to draw a curved line that goes through all of the points, so you must go through all of the points, and it also must, and this is from the mark scheme, follow the general trend of the line. So for example, and I'm going to do this wrong, but for example, if you went up and went off this way but came back, you can't say it's a curved line. It must follow the general trend. There you go. So it should look something like that. A couple of things to avoid when you're drawing a curved line. Do not start doing this with it to get a nice curve on it, because that is what they call feathering, and in an exam that will be marked incorrect, because mathematically it's incorrect because you've got 2 different lines there. So do not do that. And let's just check all of my points. Am I going through each one exactly? I've gone a little bit low on that one, I think, to be honest with you, but I think we'll get away with that. Yes, I have gone through all the points exactly, so that would get me the 2 marks for that question. The next one, it says use your graph to solve x squared minus 2x equals 2. It looks tricky, but it's actually fairly straightforward. Because it says equal to 2, you need to draw a line that goes across here at 2, and your answers are where this line you're drawing crosses these lines here. So let me zoom in a little bit. So the solutions to it are, and if we come down from there, that will give me about 2.8 for that one. So the answer is 2.8, and just put that on the answer line down there. And the other answer, we come down from here, is minus 0.6 or 0.7. Let's call it minus 0.7, I think, or minus 0.7. You're going to get slightly different answers to me for that, because everybody's graph is a little bit different because of the way we do the curve. The mark scheme says for this one they'll accept any answer between 2.6 to 2.9, and for this one they'll accept any answer from minus 0.6 to minus 0.9. So when you do it, as long as it falls within those boundaries, you will get the marks for it, but you must show what you're doing up here. Okay. By the way, if you don't really understand what I've done and this comes up, just have a go at drawing it across there and reading off the x-axis. Could be 2, almost 3 marks for you. Next one, and this is the final one, question 22. This is a good one to end on. Right, a sculpture is formed using a cylinder on top of a cuboid. Before I even read the rest of this question, I thought it was going to be a volume question. It actually goes on to be density in a minute, which we'll talk about in a second. But the first thing you've got to do basically is find the volume of each of these shapes. So what I've done the cuboid and I've done the cylinder, and I'll talk you through them. If you've got the exam paper in front of you, that's really handy because you can look at the sculpture. It's a little bit small, this, so I'll leave that there, and I'm going to zoom in now on my working. So the cylinder, first of all, you need to work out the area of the circle on top, or as I call it, the cross section of the cylinder. So that's pi times the radius squared. and the radius of the cylinder is 45 centimetres. It says so in the question, and that gives you 6,361. Don't round up, put all your decimal points in. We'll round up at the very end if we need to. And you multiply it by how long the cylinder is, and the cylinder is 80 centimetres long, so I've rounded it by 80. So that there is the volume of the cylinder, and there are the workings for it. You can pause that if you want. Next one, the volume of the cuboid's a little bit simpler. I try and encourage my students to work out the area of the cross section, which is one face of it, and multiply how far it goes back. But I'll be honest, with a cuboid, you just multiply them all together, and that gives you, is that over 1 million, I think, centimetres cubed. That puts squared for that, cubed. Look at that, naughty me. Right, so that's the volume of each part. Now you need to add them up. So my total volume is that. I suggest you've probably got 2, maybe 3 marks for getting this far. An important part about my workings here is look how clearly it's laid out. I've labelled what I'm doing. And for every question you're doing, like this, where there's 5 marks involved, you must tell the examiner which bit you're doing, so he or she can find it fairly straightforwardly. Right, the next bit of the question, it says the sculpture is made of granite, which is a type of rock. The granite has a density of 2.7 grams per centimetre cubed. That means for each centimetre cubed, and a centimetre cubed is something, and I'm trying to do this to scale, is something like that. It weighs 2.7 grams. Obviously that's not very heavy. Give you a bit of context, a packet of crisps weighs between 25 and 30 grams. So you only need about 10 of these little cubes to weigh the same as a packet of crisps. Obviously granite is very dense, so you don't need as much of it. Right, you need to know your formula for density, mass and volume. I've got my little triangle here which I use. You might have learnt this in physics as well, but it is on the maths curriculum, so you do need to know it. It's a bit like the speed, distance and time one, but obviously it's for density, mass and volume. We're told the density, we've worked out the volume, so the question is, what is the mass? So mass is density times volume, so the density is 2.7 and the volume is that one there, which I've got from over here, and that gives me this number here in grams. You probably got 4 marks if you got to this stage, to be honest with you. It does say it wants it in tons, so what I've done is converted grams to kilograms, and I've done that by dividing by 1,000. Again, you need to know there is 1,000 grams in a kilogram, because kilo means 1,000, and then you also need to know there is 1,000 kilograms in a ton. So again, I've divided by 1,000, and the answer is 4.654. I'll leave those workings there if you'd like to pause that and have a closer look at it. That's the end of the paper. Again, grade boundaries, it's only the second year they're doing this one. I think last year it was about 40 or 45 on the OCR one you needed for a grade 4. For a grade 5, I think you're looking at the mid-50s, possibly higher. I suspect they'll go up this year as the schools get the hang of the papers and the students have more practice at them. Wish you the very best of luck.